Good day, everyone. I am Jasmaya Clarice Picastas, and I'll be discussing the applications and advantages of hydrometallurgy. So, first, let us discuss the applications of hydrometallurgy. So, as we all know, hydrometallurgy is widely applied across various industries, offering a sustainable and energy efficient alternative to high temperature methods. So, the following that I'll be discussing are the four main applications of hydrometallurgy. So, first, hydrometallurgy is um, used for primary metal extractions from ores. So specifically it is utilized in the mining industry for extracting metals from ores, proving particularly advantageous for low grades and complex ores that are difficult to treat using pyrometallurgical methods. So, in primary extraction, a chemical solution called lixiviant is used to dissolve the desired metal like copper or gold directly from the ore, making it easy to separate and purify compared to high heat. So, unlike pyrometallurgy, which is energy intensive and often inefficient for low concentration ores, hydrometallurgy uses chemical processes like leaching to dissolve metal values. So, for example, major applications include copper extractions, where sulfuric acid leaching is commonly used for oxide ores, followed by the um, solvent extraction and electrowinning. So similarly, gold extraction also employs cyanide leaching. So ultimately, this application is for maximizing resource utilization as primary deposits become increasingly complex and lean. So a second key application is in recycling and secondary resource recovery. So, hydrometallurgy is applied in recycling of secondary materials such as um, electronic waste, batteries, and industrial byproducts. So, this approach helps recover valuable metals and separating them. Waste materials like electronic trash and spent batteries are complex mixtures, but hydrometallurgy's chemical selectivities allows engineers to recover specific valuable metals such as lithium, cobalt, nickel, gold, silver, and copper that would otherwise be landfilled. So, for an instance, in battery recycling, techniques like leaching and solvent extractions are employed to recover these critical metals. So, consequently, by recovering these resources, hydrometallurgy enhances resource utilizations and reduces dependency on re, primary resources, directly addressing the growing demand for materials in electronic devices and green technologies. So the next one the third one is hydrometallurgy is employed for environmental applications. It is applied to clean up contaminated sites and water by using specific chemical processes to capture and remove toxic heavy metals from wastewater and mine residues. So the core principles are the same ones used to recover valuable metals, but they are reversed or modified to remove contaminants. So techniques such as precipitation and ion exchange are used to separate specific metals from the aqueous phase. So while hydrological processes must be must be managed properly, the technology itself is successfully used to remediate environmental issues caused by mining. This capability highlights the hydrometallurgy's role not just an extraction method, but as a critical environmental engineering tool for proper waste management. So finally, the last but not the least is hydrometallurgy is also utilized in production of high purity metals. It is used to produce high purity metals for various industrial applications, particularly in high tech products. By employing advanced methods like solvent extraction and electrowinning, hydrometallurgy al- hydrometallurgy allows for multiple high controlled purification steps to produce with the extreme purity required for applications like microelectronics and permanent magnets. So this is because the sequential steps of hydro hydrometallurgic circuits like leaching, then solvent extraction or ion exchange, and finally electrowinning or reduction provide paralleled separation efficiency that conventional smelting cannot achieve um, without extensive post processing. So, as a result, the process is essential for high purity materials like rare earth elements, which are extracted from ores using acid leaching, followed by the solvent extraction and precipitation to achieve the necessary high purity. Now, let us proceed to discussing the advantages of hydrometallurgy. So, first in the list is that hydrometallurgy is presently employed to create over 70 metallic elements, and it involves selective separations in field like battery recycling, which results in salt extraction. After desorption of the absorbed ions, ion exchange lead to a variety of separation and recovery procedures for metals at low concentrations. So the foundation of this advantage is the chemical selectivity. So unlike heat, which is often melts everything together, this liquid re- this liquid solvents can be tailored to dissolve one specific metal, like copper, gold, or nickel, while leaving others behind. This is crucial for urban mining and battery recycling, where complex mixtures of materials must be cleanly separated to recover high purity salts and metals like lithium, cobalt, and manganese. So, the use of this ion exchange is key to achieving high recovery rates even from very dilute streams. So the second advantage is that hydrometallurgy is capable of extracting metal from complicated ores. So as high grade ore deposits became depleted, the industry must turn the resources with a lower metal content or more complex mineralogy. So while pyrometallurgy struggles with these materials due to high energy costs and potential for increased harmful emissions. In hydrometallurgy, it's specifically um, what in hydrometallurgy we have specifically techniques like bioleaching, which uses microorganism or pressure leaching, can effectively dissolve target materials from rock with concentrations as low as 0.5 percent or even less. So this makes previously uneconomic deposits viable. So the third in our list is that hydrometallurgy has a modest investment cost compared to building a massive smelter, and handling material is simplified. So a major metallurgical facility such as a leaching plant often requires less extensive and specialized high temperature refractory equipments than a large scale melter. So furthermore, the handling of These materials are simplified because the main medium of transport and reaction is liquid, which is the slurry and the liquor. So flowing through pipelines, tanks, and pumps rather than managing a large volumes of solid or concentrates and molten metal. So the fourth on the list is that hydrometallurgy is significantly more um, environmental friendly. So the most significant environmental fact is the reduction of sulfur dioxide emissions. So in pyrometallurgic smelting, as we all know, the smelting of sulfur in pyrometallurgy, um, as we all know, smelting of sulfide ores releases large amounts of this sulfur dioxide as a precaution to acid rain. So here in hydrometallurgy, by operating at the low temperatures and focusing on the chemical dissolution, it avoids these emissions most entirely. So instead that the sulfur is typically instead of that the sulfur is typically converted into a stable solid element, sulfur or gypsum, which is much easier and safer to manage. So the seventh advantage is that it has a greater control over each stage of processes leads to a recovery of valuable byproducts. So the liquid mediums allow for fine tuning of parameters like pH, temperature, and reagents concentration, giving giving engineers precise control over which elements are dissolved and when. This allows sequential extraction, enabling the recovery of secondary metals such as molybdenum and rhenium from copper concentrates or nickel and cobalt together. These byproducts, which might be lost to slag in smelting, add significant economic value. So the sixth advantage is that hydrometallurgic methods eliminates the need for coke, an increasingly expensive reducing reagent. So while in pyrometallurgy, we it especially in steel or in iron production, it requires carbon-based fuels like coke or coal to chemically reduce metal oxides to their element form. This is a significant operational cost and a source of carbon dioxide emissions. So these are all removed or lessened in hydrometallurgies hydrometallurgy processes we relies which it relies on chemical reactions only in solutions like electrowinning or precipitations, often using electric energy or simpler non-carbon reagents, thereby cutting reliance on the cost of coke. So the seventh advantage is that seventh and last, uh, finally, the advantage in hydrometallurgy is that liquor waste from the last recovery process may be recycled. So the solution left over after the target metal has been recovered through electrowinning or solvent extraction is often still rich in acid or leach reagents. So this spent liquor is typically directed back to the initial leaching stage to dissolve more fresh ore. This closed loop recycling drastically reduces the consumption of new acid like sulfuric acid and minimizes the volume of actual wastewater or the final wastewater that needs treatment, making the overall process more sustainable and cost efficient. So in summary, hydrometallurgy represents a cleaner, more flexible, and economically robust approach to metal extraction, positioned perfectly to handle the challenging low-grade resources and complex recycling demands of the 21st century. So that would be all for my report. Thank you everyone for listening.